Small angle approximations proof. The proof is not in the exam, so you could just completely skip this video. It's not necessary. So we need to prove these three relationships. So we start with the circle, sector, arc length is r theta, given by this formula. Making a right angle triangle, the length of this side, or the height of the triangle, is r sine theta. Now let's make the angle theta small, so we're essentially taking this point and moving it along here, along the arc, until theta becomes really small, something like this. The blue line, which is a part of the triangle, and the red arc, which is a part of the original circle, are very similar in length. And that's true for small angles measured in radians. So we can say r sine theta here from the triangle is approximately equal to r theta, the arc length. And if we do this, then we get the first relationship, that sine theta is approximately equal to theta for small angles in radians. Graphically, if we sketch on the same graph y equals sine theta and y equals theta, we can see that both graphs do have an overlap around here. So that's true for small angles in radians along here. Okay, so the tan theta is approximately equal to theta next. So again, we start with the same diagram. The length along here in the triangle is d. The triangle starts here and ends there along here, so that's d. So just a triangle. The height is now d tan theta. So now we're going to make theta smaller again, like we did before. And we can see that d tan theta here, the height of the triangle, is approximately the same as the arc length, r theta. And the approximation improves the smaller the value of theta. Now d is approximately equal to r. In this diagram, d and r look different. But if this point moves along here as theta gets smaller, the value of d and r is very similar. So replacing the d with r and then cancelling r on each side, we get the second approximation relationship. Now graphically, if we sketch y equals tan theta and y equals theta on the same graph, once again we can see there's an overlap in this region. So for small angles along here, measured in radians, the graphs are similar. So tan theta will be approximately equal to theta. But as theta gets larger for positive or negative angles, then the graphs separate and the approximation breaks down. Okay, the last one, this is for cos theta. So let's start with a double angle formula for this, and it's one that you're familiar with, this one. And we're going to replace the x with theta over 2. So we now get this. And we know that sine of an angle that's small and measured in radians, which the angle is, will give you approximately just what the angle was, theta over 2. So we need to replace this part here with theta over 2, but this was squared, so I need to square both sides like this. So now we've got this, simplify, and this is the third approximation relationship. Graphically, we can see the graphs are similar here for cos theta and 1 minus theta squared over 2, so you can see both of these sketched together, and they overlap here for small values of theta. Values of theta around here. And as theta gets larger, whether it's positive or negative, the graphs separate and the approximation breaks down. An alternative way to get the same approximation relationships is to do a Taylor series expansion. There's a formula for it here, and some more information here. And the Taylor series expansion for sine theta gives you these terms, and there's an infinite number of terms it goes on. And we know that if theta is small, then terms like theta cubed and theta to the power of 5 and so on are almost zero. So if we ignore those terms because they are almost zero, then we end up with this, which is our sine approximation. And we can do the same with the tan approximation. So theta to the power of 3 onwards, if we ignore those terms, we get this, as we did before. And then for the cosine one, if we keep the theta squared term, everything else goes, and we're left with the approximation as before. But once again, the proof for the approximations is not in the exam.